Today I'm speaking with John Alobri, Marketing Director of AEMC, who will be discussing some of the products and services that AEMC offers. What current trends are impacting the electrical testing instrument industry, and how is AEMC responding to these new developments?
The current trends that we've seen over the past year and even further back than that is a lot more emphasis on the ability to add intelligence to the instrumentation. For example, where in the past you may have an instrument that you'd connect up to do a measurement, you would take the measurement and display it. You would then have to apply that answer to a formula to get the desired information that the technician or the engineer would be looking for. Today, all those formulas are built into the instruments, so that the instruments are intelligent enough to provide the end answer for the customer, just saving a significant amount of time and money. And we see more and more of that applying across all kinds of instrumentation, from handheld multimeters to insulation testers to power analyzers to ground resistance testers. It's pretty common across the industry. Secondly, we see a lot more communication taking place between computers and instrumentation, where tests can be run remotely over the internet now with Ethernet connections and Wi-Fi connections or Bluetooth connections. So there's a lot more sophisticated communication between the instrument and the computer, and a lot less operator intervention to get the job done. And basically that's what AEMC has been involved with. We're adding all this kind of capability into just about every instrument that we make today, and all the new instruments that we'll be introducing to the marketplace in the next 2 or 3 years will be incorporating more intelligence, more up-to-date communication.
Why are AEMC Instruments' new handheld oscilloscopes ideal for field testing and troubleshooting?
The handheld oscilloscopes that we offer to the market have a very high resolution. Typically, most handheld scope type products that are out there are 8 to 10-bit resolution. We offer a 12-bit resolution, which means, in simple terms, as you zoom up and try to analyze smaller pieces of data, we're not just spacing out the dots, we're actually displaying more real data points than some of the instruments out there. There's also channel-to-channel isolation. So on our 4-channel scope, we have significant electrical isolation between channels, which means one channel could be measuring a very high AC voltage, for example, while the other is measuring something that's DC or even a non-electrical phenomena without interference between one parameter or the other. Also, we take a lot of the guesswork out of the technician's hands when the accessories and the probes and the interfaces that we can plug into our handheld oscilloscopes self-identify and self-calibrate. So what we do there is significantly reduce the amount of setup time that it takes the technician to take the scope out of the box, get it out in the field, connect up, do the measurements. A lot of the setup work is done by the machine itself, eliminating a lot of technical hand-holding. It's also a combination oscilloscope with a graphical display where the technician can see what's going on, and it's a data logger as well. So not only can you make on-site decisions, you can record the data, go back to the office, analyze it, provide a more thorough solution to the customer.
Please describe the primary features of AEMC Instruments' new digital transformer ratiometer, DTRR Model 8510.
The DTR 8510 is a second-generation product for us. It's following the heels of a very successful Model 8500. The 8510 adds the ability to measure transformer ratios. That's its primary function. The electric utilities and other industries, before they put a power transformer, a voltage transformer, or a current transformer into service, they have to verify that the turns ratio, primary to secondary, meets what the manufacturer's specification says it should read before putting that into service. If they put a defective transformer into service or one that's mislabeled, it could cause some significant electrical problems to the network. So a transformer ratio tester provides the ability to verify that ratio prior to putting it into service. And our older model, we measured ratios from as low as 0.8 to 1 up to 1,500 to 1, where the new one will go up to 8,000 to 1. So we've greatly expanded the measurement range of the unit. We've also built into the ratio tester the ability for the operator to store 10 of their most popular transformer ratios. So if a technician in a utility yard is going to test several different types of transformers, he can quickly recall from memory what the manufacturer's ratio is prior to running the test. Then once the test is run, the instrument will show him or her the ratio that it actually measured, and then give him a percent deviation from what the manufacturer said the ratio of that transformer was. So you're getting significantly more data on the test than you would in the past. And last but not least, picking up on some of the points we talked about earlier, a lot of automated features are into the unit, so the operator doesn't have to make as many decisions. Data can be stored in the 8510, could not be stored in its predecessor. Tests can be run from the computer, and automatic reports can be created. So we eliminate the need for the operator to have to write down the test results after the test. It's stored in the instrument, it's played back to the computer, and the computer can then print the report in hard copy directly to a printer.
Thank you so much, John. That was extremely informative. For more information on AEMC, visit rideouttool.com.